All right, so first up, it looks like it's asking us to find the area of the shape. They give us a little bit of information. They tell us that BA and BC are 6 centimeters. So these two guys here are 6 centimeters. Perfect. And very conveniently, they actually give us that the triangle is a 90-degree triangle. The reason I say that that's so convenient is because there's a lot of formulas and equations that we can use. So whenever you see a 90-degree triangle, it's important that all of these formulas bubble up to the surface. It's asking us for the area, so straight away, because it's a 90-degree triangle, I can just go area of the triangle is half base times height. In order for this formula to work, it's perpendicular height, and of course, there's 90 degrees. So I can use this as my base, and this is my height, or vice versa. So half base is 6, height is 6, and we're going to multiply those together. So we get 18 centimeters squared. Wonderful. Now, in order to find the area of my circle, I'm going to use the formula pi r squared. And we just need to remember that pi r squared will give us a full circle. So we're just going to also straight away put that half in there so that we don't forget about it later. Okay, now this is the only part that we're really missing. Pi is a constant, so we don't need to worry about that. So we just need to try find r. In order to do that, thankfully, because it's a 90-degree triangle, we can just use Pythagoras. We've got two of the sides, so we've got a squared plus b squared equals c squared, and my a is 6 squared plus 6 squared equals my side length that I'm looking for, which is AC squared. And I'm just going to flip it around so that it looks a little bit neater. I like to read left to right. Adding all those together, we get 72. Then, finally, just to get AC by itself, I'm just going to square root both sides. So I get AC equals to 6 square root 2. I'm going to leave it in surd form just because it's a little bit neater and I don't lose accuracy. Right, so now AC is the entire diameter and we only need half of it. So I'm just going to divide my AC by 2. So my radius is now going to be 3 square root 2. And now I can just plug that straight into my formula and carry on working out the area of my circle. So that's a half pi, and I'm going to plug that in 3 square root 2. Please remember to use brackets so that when you're using your calculator, it doesn't misunderstand what you're wanting it to do. Putting all those together, we get 9 pi. Fantastic, but don't get carried away. We now still need the total area, which is area of my circle plus area of my triangle. So 9 pi plus my 18, which I had. And now at this point, we can then we can get rid of my pi, and if there was a surd, get rid of a surd, and just write down what our calculator is asking us to calculate. And then we just need to remember right in the beginning, they told us that we needed to work with 1 decimal place. So we just go round that off and it becomes 46.3. And when writing it on the line, it has our centimeters squared there for us. The next question says, write 8a as a product of its powers of its prime factors. Okay, so they've given us a up there, and now they're just saying 8 times a. So I'm going to go straight to that. 8a equals 8 times everything that I've highlighted above. I'm going to put the 8 straight into indices form. So I've got 2 to the power 3 times 2 to the n times 3 times 5m. Using indices rules, we're going to say 2 to the power 3 times 2 to the power of 2. When we do that, we can just say 3 plus n times 3 times 5m. And that's our final answer. Question 11 asks us to work out the upper bound for the value of c. in order to find the upper bound for C, in other words, the largest possible value, I would need to take the biggest value, so my upper bound of B, minus the lower bound of A, which would result in the biggest possible number. If I took the upper bound and the upper bound, I'm not going to get as big a number as if I took a big number minus a small number. Either way, I always recommend saying A upper bound, A lower bound, B upper bound, and B lower bound, and then just writing them out anyway. So 6 correct to the nearest integer. So in order to work out upper and lower bounds, we're always going to have a look at that divided by 2. So my nearest integer, I'm going to say 1 divided by 2. So I get a 0.5. To get the upper bound, I just add, I take my number and I plus 0.5. And to get the lower bound, I take 6 and I minus 0.5. For B, it's correct to the nearest 5. So again, 15. Upper bound, I add 2.5 because it's half of my value. And then 15 minus 2.5. And this way, whatever the question throws at you, you know all the information and you don't have to think about it again. And that's 12.5. All right, so there's our upper bounds and lower bounds. We've already decided right in the beginning that I'm going to use upper bound minus the lower bound. So we're going to take B's upper bound minus A's lower bound. So upper bound for C is upper bound minus lower bound, and that is 17.5 minus 5.5. So we get an answer of 12. Question 16 asks us to find the sum of the first 100 terms of this sequence. Thankfully, right in the beginning in your formula sheet, you are given a formula that says n over 2 2a plus, in brackets, n minus 1 d, close your bracket. So you're actually given this formula, so you don't need to remember it. You just need to remember what each of the items is asking for. So my first term is equal to 7, and that's a. The difference is equal to 3, because from there to there to there, it's jumping up by 3. So in between each term, it's going up by 3 each time. And that is D. My last term, find the sum of the first 100 terms. So my last term is the 100th, and that is my n. So from that point on, I'm just going to be plugging in the values. That's why it's so important to write all your information out. From this point, you don't even need to think, you're just plugging it in. So it's n over 2, so that's 100 divided by 2, in brackets, 2 times 7 plus bracket n is 100 minus 1, and my d is 3. Now that I've got all of that, 100 divided by 2 is 50. In my brackets, 2 times 7, 14, plus 100 minus 1, 99 times 3, we get 311. Multiplying those together, I get 15,550 as my answer. Question 17 is a similar shapes question. So shape A or vase A is similar to vase A, and that just basically means that their proportions are the same. So vase A is 24 centimeters in height, and vase B is 36 centimeters in height. So looking at the question, vase A has a surface area of that, work out the surface area. So because it's similar shapes, we can get a scale factor. So we're going to work out the scale factor of one to the other. So if we say my scale factor is 36 divided by 24, and that's just how they compare to each other. So we get 1.5 as my scale factor. A very, very important piece of knowledge is when using scale factors, you get a linear scale factor. Then when you're going into area, or I'm sure later on they're going to ask us about volume, you just need to remember to convert your scale factor. So here we say vase A has a surface area of that. All right, so just remember in our original scale factor, we said B over A to get my scale factor. So we're going to do something similar. So that equals my K value. Now we just need to remember that we're going to be using not the linear, but the area scale factor. So we had 1.5 squared, and then we have, well, we've been given A, so we got 960 centimeters squared. So if I want to work out the surface area of B, I'm just going to get rid of this, so times up 960 times 960, because I want B by itself. And doing that, we get 2,160 centimeters squared. Okay, as before, we've got vase A, vase B, except now we're working in volume. So we'll put the equation exactly the same. We've got B over A, and that equals my scale factor, except now it's cubed. For this section, just to make my life a little bit easier, I'm going to use it in the fraction form. So if we went up to this one over here and we simplified it and brought it down, we'd get 8. So V of volume of B over volume of A. And just to make our lives complicated, they used V, so I'm going to replace it with a color. So that is B over there, and now I've still got volume of A underneath equals to this 27 over 8. So I want VA by itself. So in order to do that, I'm going to times 27 over 8 by V of A, and of course I want VA by itself, so I need to now divide both sides by 27 over 8. So on my next line I'm going to get V of A, and that equals to my blue V divided by 27 over 8, and of course we don't like division of fractions, so we're just going to get rid of that completely and say V times 8 over 27. So making that nice and simple, VA equals 8 over 27 V. Okay, so a solid is made from a hemisphere and a cylinder. The plane face of the hemisphere coincides with the upper plane face of the cylinder, which is basically saying that my two shapes are stuck together. Okay, the hemisphere, so that is half a sphere, and the cylinder have the same radius. So these two from there to there, there to there, they are the same, they're linked together. Okay, the ratio of the radius, so my R, and the cylinder's height, so from there to there, my height is in the ratio of 1 to 3. So essentially what I can do straight away, which is quite nice, is if this is one part, this is 3 parts, so this is just 3R. Okay, so I'm going to use that later on. Given that the solid has volume 792 pi, work out the height of the solid. Okay, so I'm going to be using the volume of a hemisphere and the volume of a cylinder. So both of these formulas are given to you. So let's work with the volume of my hemisphere first, which is equal to 2 over 3 pi r cubed. Okay, and then the volume of my cylinder, again given on the formula sheet, is pi r squared h, and there it is. Instead of using h, I'm just going to use pi r squared, and I'm going to times it by 3r instead. So I'm going to replace the h with 3r. So I get a formula that says 3r cubed times pi. Is that right? Yes, 3 pi. Okay, good. And now I'm going to just work out my total volume. So my total volume is equal to the volume of my sphere plus the volume of my cylinder. So that is 2/3 pi r cubed plus 3r cubed pi. And they told us right in the beginning, or not right in the beginning, near the end, that my total volume is 792 pi. And now I just need to simplify all of this. Having a look on the right hand side, I have a couple common factors actually. First off, I'm just going to get rid of my pi, so I can pull my pi out. I get 2 over 3 r cubed plus 3r cubed, and I've got a pi on both sides now, so I can cancel them. I can divide both sides by pi, so it just cancels out. So I've got 792 equals 2 the rest, which I'm also going to simplify now at the same time. So this would be 2. I need to get a common denominator because I'm now adding fractions. It's going to be 3r cubed plus, in order to get this one over 3, I need to times by 3 over 3, so I get 9 over 3r cubed. And then now, because they have a common denominator, my r cubed stays the same, and it's just 11 over 3 and 792. And now, of course, I want r by itself, so I can times by 3 on both sides, times by 3, and I'm just going to do it all at once, divide by 11, because that will cancel with that. So we get r cubed equals to 216. And then to get r by itself, I'm just going to cube root and cube root. So r equals 6. But don't forget, they asked you work out the height of the solid, and we have just got the radius, but they also told us it's in parts, so we know that the height is 3 times my radius, so 3 times 6, so my height is 18. Okay, and then as always, just make sure that you have actually answered the full question. It says, given that that is, work out the height of the solid. So it's not just this height, it is the total height. So we've worked out what this height is, which we got down below as 18. And then this height over here is just the same as this piece here, which is my radius. So to get my total height is equal to the 18 that I worked out plus my radius of my sphere, which gives me a total of 24. And now I'm done. All right, so next we have question 22. The graph of y equals the sine x for the range 0 to 360 is drawn on the grid. Having a quick look at it, it is a standard sine wave. By standard, what I'm saying is it's going to go from 0 up to 1 at 90 degrees, back through 0, and then back to a minus 1 on the other side. So it's a pretty standard sine wave. Well, it's exactly a standard sine wave. And it says, on the grid, draw the graph of y equals to 2 sine and then x plus 30. Okay, so that 2, first off, is going to change my amplitude. So it's going to multiply all my y values by 2. So this point over here, which was at 0.5, is now going to be at 1. This value at 1 is now going to be at 2. This value again at 1. 0 times anything is still 0, so that carries on like that. This will be 1. This will be 2. This will be 1. So that's what just the 2 does. After that, we've also got a phase shift. Now, because it's within my brackets, you would think naturally that a plus 30 would be moving in that direction. But because it's within my brackets, it's going to be inverted. So I'm going to be moving 30 degrees to the left. So just having a look, all of my blocks, each of my blocks here are 30 degrees. So having a look at the shifting that I did earlier, all of these points are just going to move like this. 1 point, 1 point, 1 point. And with that, we can then just complete it by trying our best to draw our sine wave. Now that isn't a very good version, but it's good enough for here. Okay, next up, write x squared minus 6x plus 10 in the form x minus a squared plus b. So that this straight away looks like completing the square. So I'm going to do that on my equation. So we've got in brackets x, and then remember, for completing the square, we go look at this term over here. We go say halve it, square it, and take it away. So we've got x minus 3, so that's the halve it. And then we're going to say square it, so 3 squared, and take it away, plus 10. So we get x minus 3 squared minus 9 plus 10. So we get x minus 3 squared plus 1. And that is done. Great. Next up, it says hence, which is generally a good indication that we're going to take what we learnt above there and use it on the next question. Hence, describe fully the single transformation that maps the curve of the equation y equals x squared onto the curve of the equation x squared minus 6. So, looking at this equation above us, this bracket squared looks like my x squared term over there, and then I've just got a plus 1. Okay, but in that bracket, that square part, it's not just x, it's actually x minus 3, and then a plus 1. So this is a transformation, so it's not an enlargement, not a rotation, not a reflection. It's a translation. So we're going to say it's a translation. And it is, and we'll use vector form. This part here, again, because it's in the brackets, it's inverted. So it's x is 3. And this part, my y, plus 1. And then that's us done. Alright, so the last and final question. ABCD is a kite with AB equals to AD and CB equals to CD. So with our kite, we have two sides that are equal. So it means that those two will be equal and those two have to be equal. If we have a look at it, we have AB and AD. So A is now common, and then that leaves B and D. And then C is common to both. And then it gives us some coordinates. So my coordinate of B is 10 and 19. And my coordinate of D is 2 and 7. Okay. Find the equation of the line AC. Give your answer in a certain form. Okay, wonderful. Couple of things. There is a line. There is a line. And these two lines will be perpendicular to each other. So, in order to find the equation of a line, I need it in the form y equals to mx plus c. So this is just a fancy way of developing a formula, asking you to find a formula. With most of these equations, we're generally going to start by working out that m value. If we can find the gradient of that line, because those two lines are perpendicular, I can then plug that gradient in as a starting point for developing that second equation. So let's do that. My m value, my gradient, is the change in y over the change in x. My change in y being 19 minus 7, and my change in x 10 minus 2, so we get 12 over 8, and then that can be simplified further to 3 over 2. And then if I want to find the gradient of a perpendicular line, all that happens is this is then going to flip. So it becomes 2 over 3, and we change that sign, so it becomes a negative. And now that's the gradient for that second line. Going up there. Okay, right, so now that we have a gradient for my secondary line, I can plug it in. So I've got y equals to minus 2 over 3x plus c. Now, the only step that we have left to do is to find the value of c, and to do that, I need to have two values, an x value and a y value, which I'm then going to plug into these two positions. So let's see what we can find, what value we can find for x. We know that this coordinate over there is halfway between B and D. That's testing your knowledge of a property of a kite. In order to find that midpoint, we're just going to take my two x values, add them together, so I get 12, and divide that by 2. And my second coordinate, I'm going to take 19 and 7, add that together, we get 26, divide that by 2. So a coordinate that we can use now is 6 and 13. Now that I have this coordinate, I can plug it into this value to figure out what my final step is. So I'm just going to do that. We take 13 equals minus 2 over 3. My x was 6 plus c. Simplifying this a little bit, we'll get 12 over 3, and then 12 over 3, so 12 divided by 3, we get minus 4 plus c. Bringing that 4 across, we get my c value being 17. So my very last step, plugging all that into my final equation, we get minus 2 over 3 x plus 17. And then just remembering to read our question carefully, they actually told us over there that we need to present it to them in a certain manner or a certain way. So let's do that. We just go rearrange. So I want y. I'm going to bring my x across to the other side. 2 over 3x equals 17. And I don't want that 3. So I'm going to get rid of it. So I'm going to times everything by 3. So I get 3y plus 2x equals 51. And that's my answer.